We are given a long steel rod, so we have circular section here, and diameter is given as 4 cm. The surrounding temperature and wall temperature is given respectively T0 equal to 200 degrees Celsius, surrounding temperature is given as 30 degrees Celsius, so we have T infinity equal to 30 degrees Celsius. Thermal conductivity of the rod is 50 watts per meter per Kelvin, and the heat transfer is given as 18 watt per meter square Kelvin. You want to calculate the heat transfer from this one. First of all, we'll calculate the parameter m, which is under root of P into H by K into AC. So this time we're going to substitute for perimeter and cross sectional here itself. So perimeter is pi d for circular section. We have H, K, AC is pi by 4 d square. So what we get is 4 times H by KD. So this will give exact answer of m. So substitute all data and you will get this answer exactly equal to 6. The fin is long. So for long fin we have PQ equals to under root HPKAC into theta 0. So just go on putting all data. H is equal to 18. Perimeter is pi into D, that is pi into 0.04. Thermal conductivity is 50. Cross section area is pi by 4 into D square, and D is 0.04 square. And theta 0 is basically T0, that is 200 minus T infinity, that is equal to 30. Solve this answer, you will get 64.088. So choice C is correct choice. In this numerical, we have aluminium K equal to 204, rod 2 cm in diameter. We have a rod, so we have a circular cross section. Thermal conductivity is made up equals to 204. Diameter is 2 cm, that is 0.02 meter. It is 20 cm long, so L equals to 0.2 meter. The wall is maintained at 300 degrees Celsius, so we have T0 equal to 300 degrees Celsius. The end of the rod is insulated, but we'll confirm this. Value of T infinity is equal to 30, H equal to 10, and he says that assume TP is insulated. So we have formula for Q equals to under root HPKAC into theta 0 into tan hyperbolic ml. So first of all we'll calculate m, and it is circular section. It is known that this value will be equals to 4 times H by KD. So you can put for this value, it is under root of 4, H is 10, K is 204, and diameter is 0.02. So this answer is 3.13. Just substitute all value. H is 10, perimeter is pi d, pi into 0.02, K is 204, AC is pi by 4, 0.02 square, theta 0 is 300 minus 30 into tan hyperbolic. Value of m is 3.13 and L is 0.02. So if you substitute ml, L is 0.042. If you substitute all value, you will get answer equal to 30 watts. Okay, this is cylindrical fin, K equal to 30. So again we come across cylindrical fins, K is equal to 30. Diameter is 2 cm. Section is circular and it protrudes 10 cm, means L equal to 10 cm. T paint is insulated and value of H is given as 70. You have to find out fin efficiency. So recall that efficiency is given as the heat transfer with fin divided by the maximum possible. So it is under root of HPKAC into theta 0 into tan hyperbolic of ml, and for maximum heat transfer we have surface area AS into H into theta 0. So cancel this value, theta 0 and theta 0. Next job we can calculate m first. For circular section we already done the value of m, and the m is equal to 4 times H divided by KD. You can substitute for m 4 H KD and get this answer equals to 21.6. This is 4, H is 70, K is 30 and diameter is 0.02. So this answer is very close to 21.6. Now substitute all this value here. Step by step we can solve this. Put for K equal to 30. D equal to 0.02, L equal to 0.1 square, H equal to 70, tan hyperbolic of 21.6 multiplied by 0.1, and confirm the efficiency equals to 45%. So it's a very poor quality of fin. Efficiency should come approximately 90%.